So this is chapter 5, number 17, and this will be part B. Oops. Alright. It asks what the force is that each crate exerts on the other. Now we could figure it out. First the 65 kilogram crate, and then we could do the 125 kilogram crate. But since we know Newton's third law, which says every force action has an equal and opposite reaction force, so we only need to find one, and then we automatically know the other. Let's do a free body diagram of only one of the boxes. This will be the 65 kilogram one. So it's got force of gravity. It's got the applied force going straight on it. It's got the force of friction. And it also got the force that we're trying to find. The force of box 2 on box 1. All those little arrows. With this, the mass is not a vector, so that doesn't need an arrow. But gravity is an acceleration, and an acceleration is a vector, so you put an arrow on that. Okay. So, there's the normal force. I didn't draw. I was wondering, how come it's not falling down? Okay, normal force. Again, in the y direction, 0 net force. So let's just go straight to the x. Sum of the forces, this is sigma, sum of the forces in the x direction. Well, the biggest force is probably the applied force, so I'm going to put that first. That's going to be a positive number. I'm going to choose positive to be going to the right and negative to the left. So minus the friction force and minus the force of box 2 on box 1 equals, well, we know it is accelerating, so it does 0, it equals ma. The sum of the forces equals mass times acceleration, and this is mass 1. Okay, now let's spell it out. The force, the applied force, we know that number. We're trying to find this number. So the friction force is mu k mg. That's the mass 1. Okay. I'm going to use algebra to move that over here on the other side of the equation, and I'm going to use algebra to move this one on this side. So I'm going to subtract m1a. Now the force of the second box on the first. So I know this number, I know this number, I know this. This number, I'm going to plug in the entire number here. I want to make sure it's as precise a result as possible. Once again, to save time, I'm not going to actually write out all the numbers. But you see that we have each one. This is 0.18, this is 65, this is 9.8 meters per second squared, 65 kilograms, 1.65705, etc. meters per second squared. Okay, and that will give us this result. It comes out to this is an arrow. Alright. The answer comes out to 427. Wow. There we go. 427.6315.789. Oops. 789 newtons. Alright, there's a 9 here. So that equals 4.3 times 10 to the 2 newtons. So that's force of box 2 on 1. Again, with Newton's third law, we know that the force that box 1 applies on 2 is the same thing. 4.3 times 10 to the 2 newtons. Okay, we're done with that part.